Hello again, this is Tim Baldridge, and today we're going to talk a little bit about transients. This is probably going to be a two-part series on transients, and hopefully we'll address some of the issues around understanding how they work and kind of how to work with them. When working with transients, I notice a lot of people tend to do things in a slightly incorrect way. And this is because the documentation around transients is very precise, but it doesn't really explain why they are the way they are. So we're going to make a very, very simple data structure today. And then we're going to look at how we would make it support transients. So we're going to create a type today. But before that, we're going to create a simple protocol and call this iArrayCollection. And this is going to have a couple of operations. It's going to have a nth, this idx, and it's also going to have a append, this val, and it's going to have a replace, this val. And so what we're going to do here is create a vector-like structure that's backed by an array. Now we're going to create, and this won't support all of the operations that you're used to in Clojure, but you'll be able to see how this sort of thing can be used. And how more complex data structures like the persistent hash map and stuff might use these same sort of concepts. So now we're going to create something called array collection. And you know what, we could probably make this a record so that we can see the contents of it a little bit better. And we're going to have a count and an array, right? So nth, this idx, we're going to assert that the idx is less than the count, and we'll abbreviate this so we don't confuse it with the Clojure core count. And then otherwise, we're going to return a get array idx. All right, and then append this and array. And we said that's the array, and we have a val, and we're going to do this. So what we need to do first of all is, because this is a persistent collection, we need to clone our existing array. And what we also need to do is perhaps resize it. So let's see here. Let's say if the index, the count. So we want to do increment of count is less than the length of the array. Then what we want to do is let new array equal a clone. So we're going to clone the array, and then we're going to set the value of that to, actually we want to just change this to count. If count, because these are 0 indexed. So if count is less than the array length, then we're going to do that, and then do a set of the new array, and the idx, the index is going to be count, and then we will set that to val, and we are also going to do array collection, return a new collection here, like so. And we're going to increment the count. Okay. Now, if the array actually isn't big enough, then what we're going to do is we need to create a new array. So we're going to do object array of, we'll do 2x of the old size, a length of array, and then we're going to also array copy from array, and the source position is 0, the destination is new array, and the destination position is 0, and we're going to do we're going to do count items here. and then we're going to return a new array collection inc count and a set new array count to val. Okay, there we go. And then finally, you know, actually, we don't really need any of that. We can just we can remove the set, and we'll just do append. We'll make this an append-only structure for now, just to kind of simplify it a little bit. And we need array collection here. Okay, there we go. And so we can make a new constructor here that says array collection of size 0, and we can make it give an initial object array of 32. Okay. And if we run this, what does it say here? Unable to resolve symbol array collection. Here we go. There we go. So now we have our transient array collection, or we have just an array collection here with 0 items in it and an object with nothing at all. So now we could add items to it, like 1, append 2. Okay, so after a little of debugging here, it's obvious the problem here is that a set does not actually return the array. So if we do object array 42, 1, 0, it actually returns a, for whatever reason, it returns the value and not the array, which means that we need to refactor this like this. And here as well. This also needs to be put here, and we need to do array. So now this append works just like we want. We have an object array. Here we have 2 items in it, and we're counting so on and so forth. Now, based upon this, you can obviously see the problem, right? And that is, if we actually let's try making this like size of 1, and make sure that the other works. Great, it does. So the problem is every time we add a value, we do this clone, and it's copying the entire data structure, right? And you know, that may be fine. It's persistent and all that, but we can actually improve performance a little bit by having a transient append, right? So we would do something like this. We would let's create another member called append $ this val, right? And now what we can do is copy the body of this append here, and we can do one of these will have to kind of remain the same. In the case that we need to resize the array, then we are going to have to copy it. There's really no way about that. We can't resize the array. But here, there's really no reason to clone the array at all, because all we are really doing, because it's a transient operation, we're going to say as much as possible we're going to try to retain the existing structure, the existing data, and modify it in place, and then allow you to quickly change it from either a transient structure to a non-transient structure with a pretty quick operation. So let's do that. So here, if the array is large enough, we don't need any of this. We can just do a set like so. We can set the value and create a new collection with the new size. And this is giving us, oh, new array. We just want to do array. So, array collection. So now if we change these to append, it should all work just the same, which it does. We have 3 items in it now. But the difference is that we aren't doing this clone every single time. We're only doing the clone when we need to resize the structure. Now we could actually improve this a little bit more by doing something like this. We could do def type, and we can make one of these mutable. Right, we can make the count volatile mutable, and we're going to have to change here the signature of this to array collection dot, because that's how we call type, and the same here. And the same here. And we'll create our first structure here. And that works just like it did before. In fact, we can make sure that one of these is working by doing nth of that, and we'll get index 2, which is 3, the third item that we put in. So it's 0, 1, and 2. All right. Now what we can do is up here, when we don't actually modify it, we can instead say set count to inc of count, and we can return this, right? And that's the wrong append. We don't want to do it there. Yes, that's correct. Okay, so down here is where we actually want to do this. So we want to set, because we made this volatile now, count to inc of count, and we want to return this. Okay. There we go. And it still works. Now we can see something interesting. Array collection of, here we go, and we'll do this. We'll add an item to it. Dash append. Actually, we need to put this in a let. Let A is that, and B is going to be this. Right? And we got a slight error there. Here we go. So now we see these are actually the same instance of the object. See how the pointer value here is the same as it is over here. So we haven't actually returned anything new. Any new structure. We're just modifying the existing structure. Now what's interesting is we can do this. Identical A and B. If we run this, that'll return true. Now if we add a couple of items, we see that it's now false. This is because we can modify the existing structure up until the point where the structure is needs to be resized. Once the array actually needs a resize operation to occur, which is in this clause of the if, it returns a new item. So this is what the documentation for transients mean when it says that we're not supposed to bash these in place, right? You don't really want to do something like this. Let A is array collection, and then do times x of 100, and then do dash append like this of A and x. Now this will work, right? But we have a problem when we try to do nth of A, and let's do 42. Get the 42nd item out of there. Let's do dash nth. We get this assert failed, right? And the reason for that is because it only is modifying the collection up until it needs to be resized, and then it's returning a new item, or a new collection with the size increased. So that's the basics of transients. When possible, they try to reuse existing structure, and when they can't, they have to do some cloning and some working around that. Now, in the next video, we're going to actually look at how transients are implemented in Clojure. We'll probably look at maybe some of the transient source code and the Java source code, which will be fun. But we'll see how there's even more things that we have to work around. The fact that just because something is transient for one thread doesn't mean that we can just pass it around to other threads. There's a couple other rules that we'll look at for that sort of thing. But that's the basics right there, is that if we were using this on a single thread and we wanted to make this transient, it's pretty simple to do that by simply reusing the existing structure. Right, so that's it for today. In the next video, we'll look at how these, like I said, we'll look at how these are really implemented in Clojure, and some bugs that the actual source code gets around by doing it slightly differently. This code still has some bugs, but it shows the basic idea behind what we're going for with transients. So thank you for watching today.